Alright, today's lesson is on determining if polygons are similar. Okay, now the way we're going to do this here is we say two polygons are similar if they have the same shape. Well, sometimes you can tell that's the same shape, so they're similar, but if they're similar, then their corresponding angles are congruent, meaning the angles are actually equal to one another, and the measures of their sides are proportional. Okay, meaning that if they have the same shape, then our angle measurements are all going to be equal on the inside, but then we're going to see some proportionality between the side lengths happening from one to the other. A way of thinking about this here is this. Let's call this our red triangle here for now, and let's call this our blue triangle. Okay, so if I take this side here, and I take side and that side, so I'm going to call it 4/8. I could then look at this side over here, 6/12, and if there's proportional, these fractions should be equal to each other. One way to solve that for that is I could do cross products here. 4 times 12 is going to give me 48, and 6 times 8 is 48. If those statements are true, then that means these will be proportional and similar to polygons here indeed. So as long as you're doing it the right way, you're going to be okay. I could also look at it and say, let's do a little side, 4/6, and set it equal to a long side, 8/12. Okay, same thing's going to take place here. Again, I'm still with 4 times 12, right? And I still have 8 times 6, I still have 48. It still works out there okay. So what we see here is that we have two similar triangles. The side lengths are similar. They're going to be proportional sides. That's how that's going to work there again and again. Again, this says you could reduce it. 4/8 can reduce to a half. That's a half. If I look at 4/6, that's 2/3, 2/3. You end up with the same thing. Sometimes I can look at numbers here and I can find the missing value for a measurement as well. Okay, so I could say, well, here's a value here. I have a red side and a red side. I could call this a blue side and a blue side. And as long as I'm comparing the same thing, I'm going to be okay. So I'm going to go red, in this case I'm going to go red over blue. So 4/5 is equal to 3/x. Okay, so I'm setting a proportion. Red side to blue side, red side to blue side. And now, because we're saying they're proportional, I can find out what the value of x is going to be. I can cross multiply so that 4x equals 15. Divide both sides by 4, so x equals 15 divided by 4, which is 3.75. So I can solve it that way. That's one way of doing it. Okay. Another way of looking at it is I can find out what the scale factor is going to be, which is what they say to do here, from one to the other. So to go from the large to the small, okay, this becomes my small value is 3, and so the PS is 3, and this is 4. So what I know is that this one here is 3/4 the size of that one. So if I took 3/4 and I multiplied it and said, well, what is 3/4 of 5? 3/4 of 5 is going to get you 3.75. So I could use the scale factor as well. I find it's going to be easier today just to set up two proportions, set them equal to each other, and then solve for the unknown value. Let's take a look here at number 1. Okay, determine whether the polygons are similar. If they're similar, then the long side over the short side of this one should be the same proportion as the long side over the short side of this one. If we use cross products, 12 times 4 is 48, and 5 times 11 is 55. Those are not equal, therefore these are not similar polygons. This one says the triangles below are similar. They're already telling us they're similar, so find the missing measurement. Okay, well, we want the measurement of that one there, so let's go with the short side and x, so 4/x, and let's set that equal to this short side and its long side corresponding to the x, which is 15. If I cross multiply, I'm going to have 6x equals 60, and if I divide both sides by 6, x equals 10. And I get a solution there just like so. That's one way of doing it. That's probably, I think, the easiest way of solving for that there is looking at the proportions and setting up a proportional relationship to solve. Okay, I'll let you try some of those on your own, on your homework today. Give it a shot and see how it goes. All right, similar polygons. Determine whether they are similar. All right, so we're going to go with long side over short side. So 10 over 8. Is that equal to long side over short side? 15 over 12. Now I could multiply across right away. I could also reduce first. So let's reduce this to make it a little bit smaller. I'm going to cut that in half, 5 over 4. I know 5 goes in here 3 times. 3 goes in here 5 times. And 3 goes in here 4 times. So already, just by reducing, I can see that I have 5/4 equals 5/4. Yes, that's going to work out just fine. For the next one, I have a kind of a squarish shape, kind of weird. I have 100 and 101, 151, and 100. So a little weird there, but let's go with the 100, the shorter side over the longer side, setting it equal to the shorter side over the longer side. This is a little odd, not one that I would probably normally do. Okay, let's go to multiply 151 times 100, and we get 1,000 or 15,100. Is that equal to 150 times 101? And we get 15,150. Those are not equal, so these are not going to be similar. Number 4. Decide if they're similar or not. Well, okay, let's do that then. All right, so we're going to look at let's look at the length from the obtuse to the 3.1 there, and the long side, 20. So obtuse to 3 point there, and the long side, 10. We can reduce this down. 2 goes in here 2 times and 5 times. 2 goes in here 4 times and 10 times. And this can reduce down again to 2 times and 5 times. And so indeed they are equal. We would say yes. That's going to work out just fine. For this next one, okay, we have a 7, 7, and 6, 3.5, 3.5, and 3, 2 isosceles triangles. Are they similar? Are they not? Well, let's do the small side over the longer side, 3.5, and set it equal to the small side over the long side. Again, we can multiply this out and see what we come up with. Another quick thing you can do is you can also look this way, kind of a little trick here. To get from 3 to 6, I multiply by 2. What happens if I multiply 3.5 by 2? Well, I actually end up with 7. So I can tell here that by multiplication, I'm going to have a similar answer, yes. But I can also go 7 times 3 is 21, and 6 times 3.5 is also 21. So this is going to be 2 similar polygons. Okay, next we're going to find the missing measurement. So we have 8 over x is going to be equal to 4 over 2.6. So we can cross multiply. 8 times 2.6 equals 20.8 is equal to 4x. Divide both sides by 4, and this becomes 5.2 equals x. Over here we have x over 1.8 equals the long length, 6.5 over 2.6. Alright, cross multiply. We have 2.6x equals 6.5 times 1.8, which is 11.7. We're going to divide that by 2.6, and x equals 4.5. For the next one, I have a long side, 3.6 over short side, 1.5, equals a long side over unknown value, x. So cross multiply, we have 3.6x equals 6 times 1.5, which is 9. Divide both sides by 3.6. 9 divided by 3.6 is equal to 2.5 for x. And our last one here, you can pick any value you want here. We're looking for that one there, so I can do a short side 9.6 over x equals a short side over the matching one, 10. So 9.6 times 10 is going to be equal to 96. equals 6x. Divide both sides by 6. And 96 divided by 6 is 16 equals x. And that's my solution there. All right, so it works out pretty well with proportions and solving them that way with cross products. Hope that helps you out. Hope you got the idea, and we'll see you next time.